with problem of the day. Let's see what we've got here. This one says find the measure of a diagonal of a rectangle whose length and width are 12 and 16 inches. All right, so we're going to deal with a rectangle and its diagonal whose length and width are 12 and 16 inches. All right, so let's see what's going on here with this. First of all, I'm going to do a quick little draw study here. Let's put in a rectangle here. We're going to guesstimate the lengths and the widths here. By the way, they do run parallel. We do have some, hopefully some good right angles developing here. We get these things to look sharp. And we put it right here. And right here we go. Again, not really probably perfectly drawn to proportion, but we get the idea. So we are wanting to figure out what is the measure of a diagonal. Notice I said a diagonal. Oh, we said two diagonals. Well, we'll have to figure that out, aren't we? So let's put that right up through there. There's a diagonal. We're ready to go, all right? Now, notice what I said earlier, or remember what I said earlier. We have all these lovely right angles that are popping up, which create two right triangles for me, all right? So it really doesn't matter whether I want to put I'm going to put 12 here because it looks smaller than, the width looks smaller there, okay? And we'll put a 16 right there. These are in inches, all right? And this also means we got 16 and 12 here. So we've got a right triangle, 12 and 16. We got a right triangle, 12 and 16 here. If we drew a diagonal this way, we would still have 12 and 16. So my folks and my friends out there, guess what? These two diagonals will have the same length if we were to draw another one in there. But since it looks a little bit easier without the second one, let's get the first one, all right? First of all, talked right triangle. Oh man, you know what's coming. The Pythagorean Theorem, all right? So what does the Pythagorean Theorem say? It says if you take the legs and you square them and you add them together, you're going to get the sum that's equal to hypotenuse squared. Now where's the hypotenuse? That's that little creature we're looking for. We'll call it D for diagonal, all right? So let's write the formula out over here. We're going to have a squared plus our b squared equals, in this case, d squared. That's our diagonal, all right? And it was nice to you. I gave you some good numbers here. I hope everybody's already getting a good chance to stab at this thing and see what you come up with. I'm getting 12 going in for A. We're going to substitute. By the way, it doesn't matter whether you put 16 in for A or 12 in for A. They're going to work out fine. We will square. That's important. Don't forget to square. That's important. And by the way, that doesn't mean 24 either. It means 12 times 12. Those of you who are working ahead on me here. Now, 16 squared. My goodness, we'll figure that one out. Hopefully you know that tip of your tongue also. Perfect squares are nice to know, at least up through 20 squared, I think. And then we got d squared going along here with us, all right? So let's do some squaring. Let's travel right up and over here. Let's do some work right into this space. 12 squared, 12 times 12, times tables, yes, 144. A good reason to know that 12 times 12 because it pops up in a lot of right triangle situations. It's nice. It's a nice number there. How about it? 16 squared. You got that on the tip of your tongues out there? I'll tell you, it's 256. All right? Good one to know also. And then we got d squared rocking along on the tail end there. Now let's add because that's what we have to do. We have to add because if we square root beginning and don't add first, we're just right back to 12 and 16. We just might as well have added them, all right? And that ain't going to work because think about it. If you're walking from 12 and then you're going to 16, that's 28. I'm going to tell you something, folks. That D is shorter than 28, all right? Everyone can see that. So you don't add 12 and 16. Some of you are probably thinking, well, that's what we're doing in it. No, we're adding those squares. It's the sum of the squares, which is going to give us 400. Right there we go. Nice number. Why is it a nice number? Because it's a perfect square. Yeah, it's a perfect square out there. So let's square root both sides. And you say, Ernie, what would have happened if it wasn't a perfect square? We'd probably round it off to the nearest hundredth, or we'd see if we could simplify it, okay? Make it into the simplest radical form. But in this case, it's great because it comes out to 20. Now, some of you are saying, do we use plus or minus on this? Well, you tell me. We're talking about the length of a diagonal. It's got to be a positive value there, all right? So we're only going to worry about the positive 20. And folks, that's the way it works there. And many of us don't, a lot of you never heard of a 20-inch diagonal TV, but that would be pretty much your dimensions. That's, goodness sakes, I'll get that right here in a minute. That would be a 4x3 rectangle. And the old sets used to be done that way. 12x16 gave you a diagonal 20, and your price, by the way, when you do go buy TVs, when they say 40-inch TV or 30-inch or 20-inch or 42 or 68, whatever the inches are, they're based on the diagonal. So that's an important thing about the rectangle. But there you go, a little off to the side there, but we do have a Pythagorean thing. And by the way, some of you said, I recognize the triple. There is a thing called Pythagorean Triples, 12, 16, and 20. So I worked it out Pythagorean style because I think that's where most of you probably would have gone. Either way will get you where you're going. 20 is the key answer there, all right? So there we have it, our problem of the day.